Welcome back, guys. So, like you can see, we are in the Databricks environment, and we are going to use PySpark at this stage because we are not using any sample data set or real data set. So, we are going to first understand the mechanics of how the k-mean clustering algorithm work. And like k-nearest neighbor, I'm going to show you the practical implementation. So it's not like I'm calling the library, although we have these libraries available, but the only advantage for implementing it by ourselves that give us the more opportunity or more power to investigate if things doesn't go into our way, or if we want to identify the internal mechanics that okay, if some classification is going into one particular direction which is not aligned with what we are expecting, so we can investigate, right? So that's why I have actually implemented it, and this implementation has already been done, so you don't need to reinvent the wheel. But like I mentioned, if you want, that will definitely give you more power, and obviously from the understanding perspective, it will really help us to implement the algorithm by ourselves. So now coming back to the algorithm, so you can see I have two functions which I have used, and my first main function is calculate the k cluster. So I'm going to receive a data set, and obviously I need the value of k, that how many cluster or how many centroid I need to generate, and then how many iterations I need to do. And that iteration parameter is very interesting because that will help the algorithm to keep running till we reach to the local minima. And local minima means that every point is clustered into the right cluster, or every point is classified into the right cluster. So in order to reach that point, we need to keep running our clustering algorithm till we reach to that point. We're gonna see that into the later part of this video, but right now, just to describe the parameter that I'm passing. Obviously, my first parameter is my data set. K is the number of k which I'm going to use, and next iterate is more like the number of iteration I want to run. Okay, so that's my main algorithm, and then obviously I have another algorithm which is recalculating the centroid. And like I mentioned in my previous video, that in the first step we are going to pick these center randomly from our data set, and then we create the cluster based on these random picks, right? But in the next step, we are going to recompute the centroid, because now we have these three clusters, although these clusters are dirty. But what we now can do, we can recompute and refine these cluster based on the new center point, which we're going to see how we can do it, right? So now coming back to my main algorithm, let's go through the main algorithm first. So you can see I'm getting a sample, and that sample is obviously you can see I'm getting the three render points, because let's take an example. What I'm going to do, let me first, before I come back to the function, let me just show you the data set so you can easily understand the algorithm. So let me show you the data set which we are discussing. So I have a small data set with 10 random number, and I'm starting with simple just to help you understand the mechanics, and then we go to increase the complexity. So let me show you these 10 random points, and you can see it's a single dimension array, which is pointing to some random points, right? And I'm going to just pass that data set, and I want to create the three cluster, and obviously the number of iteration I want to my algorithm to keep running till it reach to the 5 iteration. And I will see whether in these 5 iteration I'm going to reach to the local minima, where my cluster are finalized and they are not changing based on the iteration. So these things we're gonna see. But before I go back into the function, let me show you the the data sets itself. So let me just draw it and try to learn the MATLAB, not MATLAB, Matplotlib, or C1, or any other visual tool, because that really help you to visualize your data. And once we are doing, especially the unsupervised algorithms, these visualization really help us to see whether the data makes sense, or the outcome which we are getting, does it really make sense, right? So you can see I have these points. So these points are I have displayed on a graph, and these are all random points, right? So the algorithm nature is quite random. It's not like I'm generating in sequence. All right, coming back to my main function, which is calculate the K cluster. So now in that one, we are passing the data set, we are passing the value of 3, and we are passing max iteration 5. So let me just, what I'm going to do. Let me just, so my data set 10 points and 3, comma 5, just for the sake of understanding. Now, K indexing, obviously, like I mentioned, I need 3 random values. So I'm just getting these 3 random value, and I'm getting the index because I'm passing the array. So it's not like I'm going to generate 3 value. I need to generate 3 random index. So in my array, I can get the values from these 3 index. And that's why I'm actually calling the range function 0 plus data set length minus 1, because it will, so for example, if I have 10 points, so length of the data set is going to give me 9, because I'm subtracting 1, and obviously I'm picking three random value between that range, which is 0 to 9. So that is going to my K indexes. All right, so result is going to contain the result, which obviously I'm going to return from my function. And K centroid, now you can see, like I mentioned, we are going to create 3 center points in this case, and then we start clustering our other points around these centers. So that's why actually I call this this array as K centroids, right? It's going to be a pure array, single dimension array, or single list of value. In either way, you can, whatever term can help you understand, you can use that. That color I have used because I'm going to actually show you at each iteration that how these centroid move, because like I mentioned in the first round, this classification or these clustering are going to be dirty. So in the next iteration, we are going to refine them based on the mean value that we're going to recalculate at each iteration. All right, so let's start, and what I'm going to do, I'm just, based on this, so now I need to fill up my empty array of the centroid that I have declared in here. So I'm just running a for loop, which is going to pick these 3 random values, indexes, and based on those indexes, whatever value we have in my data set, I'm going to store it into my centroid array. So now in my centroid array, I'm going to have 3 random value that I got from the random index generated at the start of the function. All right, so then I've actually displayed that into my scatter plot, which I've already shown you. At the moment, it's only showing you the data set, but later on, once we finish that function, you're going to see that these points are going to be these initial random centroid are also going to display on that graph as well. Okay. Now I'm going to start the iteration, because like I mentioned, so that's my first iteration which I'm going to run, and I need to run the max iteration which I have passed as 5. So I'm going to run 5 iteration to see whether my classification or the clustering is going to be perfect or not, right? So let's see what I'm going to do in the iteration. Obviously, my result is empty. I'm gonna clear whatever result I'm gonna have. And result is a dictionary. So you can imagine it's going to have a key value pair, right? So keep in mind, I'm going to later on show you that what will be the key and what will be the value. And number of shuffles, it's a flag that will tell me that, okay, how many shuffles I'm doing it. If the shuffle is going to be the 0, like none of the point is moving, or if the shuffle is going to be the similar as of the previous point, and I'm going to see that my last centroid array is not changing anymore, these are the indicator that we have reached to our local minima. So remember, it's not only like, our points are not moving. Maybe our points are moving within the same region, but the best indicator that my centroid array, which I'm every time computing, is it becomes constant, like it's become static. There is no change in it. That means we have reached to the conversion point where we are not going to go any further. All right. So my minimum distance, like I mentioned, we are going to use the distance formula. We are going to calculate the distance between the point and the centroid point, which is obviously another point in the same space, right? And we can compute the distance. If the distance between our point to these three centroid, I'm going to pick the one which has the minimum distance, and I'm going to put that cluster the point into that cluster which has the minimum distance. So my initial distance, I just define as a random, that 1000, which I believe is going to be the maximum distance, and is always going to be lost against any value, right? So instead of defining minimum distance, I just define something really unimagined value. Now, that is my selection k index, which is obviously starting with -1. That is going to be the cluster index, which I'm going to allocate to my point. And then obviously I have the cluster ID, and then I have the M cluster ID, and M cluster ID is going the one which is going to be the minimum cluster ID. So if we have three cluster, that means the M cluster ID is always reflect the cluster which has the minimum distance to my point, right? So that will be the tag of my point. Now the whole show start. What I'm going to do, I'm going to actually get the each centroid from my array, which is obviously have three values, and I'm going to now subtract my value, and you can see I'm on the top, I'm running this loop on all the points in my data set. So I have 10 points, so I'm going to get the first data point, and now I'm subtracting to get the distance. Now in that distance, I'm not looking at the sign, because the point can be the further or point can be the behind, but in either direction, the distance, whether it's going to be negative or positive, it's going to make similar sign. So I'm ignoring the sign of the distance, right? So that's why I'm using the absolute function. And what I'm saying that if the difference between my point with the centroid, the first centroid or the centroid which I'm getting from the array, if it is if it less than the minimum distance, what you do, you store the whatever the distance is into my minimum distance. So that's going to be my minimum distance. Obviously, if the next centroid has the minimum distance to the first one, that's gonna override the value, right? But then I have to do a couple of additional points. So for example, if I'm storing the minimum distance, I also need to store the cluster ID, which is, you can see, is the first point. Sorry, is the index of the centroid into my s underscore k underscore index, right? I'm going to tell you why I'm using this variable, but my minimum cluster ID, which is going to be the level of my point, I'm going to store the cluster ID into that cluster and cluster ID variable, because that is going to be the tag of my point, right? The next time I'm going to add increment the cluster ID, because based on that, I will define that whether it's going to belong to the first centroid, second centroid, or third centroid. With each iteration, you can see I'm increasing the index, so it reflects to the new class, or new cluster, which I'm comparing with the existing minimum distance, and based on that distance, I'm obviously overwriting it, right? And once the whole for loop will finish, obviously I'm going to have the minimum distance, whether it's going to be the first centroid or second centroid or third centroid, whatever centroid is going to be, that's gonna come, the distance is gonna come into here. Then I'm going to have the index of that centroid within k centroid array, right? And based on that index, I'm going to actually define the cluster tag. So you can see what I'm doing. I'm just labeling it cluster, and whatever minimum cluster ID, that's why I'm storing that index into that variable. I'm going to concatenate with the cluster value, and I'm going to tag it with the value into my dictionary. And that's why what we are doing, we are using the value or the actual point as a key, and then the value I'm using as a tag, which I'm calculating as part of my for loop which is just coming out from my centroid array. So that's the one complete iteration. Then obviously I'm going to increment, because my first iteration has completed, and now I'm going to increase the counter to reach to the max iteration. But before I go back into the loop, I need to do a couple of things. My first thing, I need to obviously see how many shuffles I'm doing. So you can see I've actually, every time I'm replacing the minimum value, that's more like a shuffle, because that I can see a point is moving from one cluster to another, or it could be a point move from one cluster to another, because we are replacing the minimum distance value. So imagine if the point is not nearer than the previous point, the minimum distance is not going to be the change, right? So whenever minimum distance is going to be the change in this line, that means some point has moved closer to, or some point moved to some other cluster, right? So that move I'm actually picking into that number of shuffles, right? So that's why I'm actually printing that number of shuffle at the end. Obviously, I'm going to print the centroid, whatever centroid I have, just to show you that these are the centroid values, right? And then I'm displaying the centroid with the data set on my plot. So I'm going to display the scatter plot of my data set, and I think I need to just do it once, otherwise keep gonna display it. So let me just take it back outside my loop. Yeah, I think that's a that's I'm already printing it, so I think that should be all right. Yeah, I don't need to reprint the full data set again and again. It just increase the intensity of the points on the graph, right? And then obviously I'm just checking if the count is less than equal to max iteration, then keep displaying the centroid on the graph, so it can show you the clustering. Otherwise, at the last point, now we reach to the end of first iteration, so we need to recompute the centroid. So how are we gonna recompute the centroid? I'm calling the function recalculate centroid, and I'm passing my result, which is obviously, like I mentioned, is the dictionary of my key value pair, and key is reflecting the actual point, and value is reflecting the cluster ID or the tag that I have assigned to that point, right? So now in the next video, I'm going to show you how we are going to recalculate the centroid. So that's the main function that is driving the k-means clustering. Or it's only have one component left, which we're going to see in the next video. Hopefully you have a good understanding of how we can implement the k-mean clustering by ourselves. But feel free to post any question, or if you have any further clarity required, more than happy to answer. Otherwise, I'm gonna see you in the next video with the recalculate centroid, which is another important point for us to reach to the local minima. Thanks for watching.